Let's get into deeper about the uses of factors and its importance by using of its gauge tables. I already drawn one rectangular profile. In this rectangular profiles, I just use a base flange tape to make a flat sheet metal. Look at it, there is a specific column called use gauge table. In that column, there are three different factors which is already placed here. We already know bend allowance, bend deductions and K factor. Also it is differentiated by mm as well as in inches. First I am selecting one of its factors called bend allowance with a sample of mm. Once it's selected, the default Excel sheet gets created. Just look at this Excel sheet. What type of gauge table it is? This is normal gauge table. What type of bending you applied in this current sheet metal? Air bending, bend allowance factors, units is millimeter. There are three different gauges are used. One is in gauge 5, another one is in gauge 4 and last one is gauge 3. These three different gauges have three different kind of a thickness. That is, in gauge 5 have a thickness of 1 mm, in gauge 4 have a thickness of 1.5 mm. Based on the factor, if you apply any type of an angle, in that angle the radius may changes by just adding a bend allowance. Because based on the angle, the radius gets changed. That is the factors which is defaultly placed. Once you select these factors, the thickness as well as the bend radius are automatically applied. You cannot able to change it because it is a default standards which is already in SolidWorks itself, like a practical applications. Just to mention any of the gauges you want, the thickness as well as the bend radius are already applied. If you want to override the radius or a thickness means you can also override it. Now if you move to another kind of a gauge table means you can move another table by just selecting it. Look at it, after I am applying any kind of an bend radius or bend allowance means it comes under these factors only. Suppose if I am applying edge flange to the particular edge, the wall gets created. But in this wall also the same kind of a thickness as well as the bend radius are formed based on our gauge table itself. Because we cannot add any kind of thickness values or bend radius in our own sections just by using a default radius. That is the difference of manual applications as well as in table applications. Okay, you cannot able to override it. It affects the entire thickness values as well as the radius values. Based on the angle also the radius may change. You can use only gauge 5, gauge 4 or gauge 3 with air bending sections. That is the exact columns with the three different kind of bend radius. One is through 2 mm, another one is 3 mm and the last one is 4 mm. Custom bend allowances we can just override your own values. Later we see in detail about this edge flange options. Now look at it, how we can apply a bend allowance in these factors. Already we know the difference of bend allowance and bend deductions in last videos by flattening our sheet metal parts. Okay, now I delete these sections. Again I create a base flange type. In this type I am just adding another kind of a table values. Before that I just delete this previous sections also. It is comes under this properties. That's why select this sketch, then use gauge table, adding a new kind of factors. In this time I am just using a bend deductions allowance. Afterwards, same as like a steel air bending, there are three different types of gauges. Once the three different type of gauges are added, now look at it, the tables gets created. This is a bend deductions factors. Look at it, it is also same as like a bend allowance, but in this time there are different kind of radius format columns are available here from 2 mm to 10 mm. What type of a bend radius you apply, based on that the K factor may changes from 0.4, 0.41, 0.42 with based on your material that things may changes from gauge 1 or gauge 2. Sorry, gauge 5, gauge 4 or gauge 3. Also if you use a K factors in the sections means it is also differs. Always maintains the K factor ratio must be 0.5 because if the ratio is 0.5 it doesn't affects your sheet metal and the overall thickness of its particular part. Because if you apply any kind of pressures or make a bend in on the sections means it not affects if you know the K factor. Because different material have a different kind of factors, you need to consider it. Same as like if you applying edge flange options, look at it based on your table the thickness as well as the bend radius gets created. If you flatten your entire sheet metal part, you can know the difference of it. If I am just flattening my overall sheet metal, look at it, what is the exact distance of this area from start point to end point. It is just 133.51. It is need to consider these factors. That is the importance of it. That's why I am repeating again and again. Because it is not like a solid body or surface body. It is a sheet metal. You just need to consider the entire factors based on our material also. Okay, these are the 3 factors just need to consider while designing a part.